Here we go, 8.6, day two, take two, because I didn't like the first video. So we're going to try it again. All right, we're going to talk about trapezoids this time. So, what is a trapezoid? If you guys remember from our measuring activity that we had, the definition of a trapezoid is exactly one pair of, we're going to say opposite sides. I'm going to abbreviate here. Opposite sides are parallel. Now, let's go ahead. I'm going to throw some letters on this thing down here. Actually, I'll go in the same order that they do here. So I'm going to call this A. We're going to call this B, C, and D. All right. So we have, this is trapezoid AB, CD. Remember, the way we write the letters on these four-sided, four and more sided shapes is going to start to matter. All right, so this is trapezoid ABCD. So I'm starting at A and I'm kind of going in that circle pattern. I'm going counterclockwise in this case. All right, so in this picture, we can say definition. I'm going to say AB. No, I'm not. I'm going to say AD. Okay, AD is parallel to BC. All right, and then I'm going to say AB is not parallel. So I'm going to put a little parallel sign with a slash through it. All right, so segment AB is not parallel to DC. And if you look at the picture, you can, pretty much visually confirm that, yeah, they're going to run into each other at some point. All right, now those parallel sides are what we call the bases. All right, so those parallel sides we're going to call base one and base two. Should I make a note of that? I'll make a note of that. The parallel sides are the bases. All right. It does not matter which one you call B1 and which one you call B2. All right. I just said the top one I'm going to call base one and the bottom one I'm going to call base two. And then I guess one more thing I do want to mention here is I'm going to put this up top, maybe a little star here. I'm going to say a trapezoid. I'm going to abbreviate here. A trapezoid is not a parallelogram. All right, and there we have it. Trapezoid is not a parallelogram. Remember, parallelogram, both pairs of opposite sides are parallel. In this guy, they're saying exactly one. All right, so that's what a trapezoid is. Now what I'm going to do is I'm going to talk about a median. Okay, the definition of the median is, I'm going to write that down, a median. I'm kind of winging this here. A median is the segment. Median is the segment that connects, let's say connects to, we're going to say midpoints. And again, I'll abbreviate midpoint. So I need some midpoints here. So let's go ahead and call this, I'm going to call this point M, and I'm going to call that point N. All right, so we can say M is the midpoint of, how about AB? All right, N is the midpoint of, how about DC? All right. And let's just kind of recall again, all right, what is a midpoint? What does that do? Well, it's going to take some segment and it's going to chop it into two equal pieces. All right, so on this first one, I can say AM is congruent to MB, and then I can say DN is congruent to NC. All right, so the left two are equal and the right two are equal. That is what a median is, right? It connects those two midpoints. What else do I want to say about this guy? Um, I'm going to say the median. Lots of stuff here. The median is half the sum of the bases. So I kind of ran out of room here. So let's see here. What can I get rid of? I got to make a little bit of room here. Here's what I'm going to do. I'm going to get rid of this, and then I'm going to make an equation here. I'm going to say the median, Mn, is going to be equal to base 1 plus base 2 divided by 2, right? That's half the sum. Sum means you're going to add the two bases together, and then you are going to chop it in half. So how about instead of saying Mn, I'm going to use lowercase m here. All right, so just m equals b1 plus b2 divided by 2. All right. I think that's really all I want to say in that guy. Actually, one more thing. A median. We've used this word before. Okay, so in our last unit, we talked about the median. I think it was in unit 5, maybe unit 6. I don't remember. We talked about the median of a triangle. So if I have like triangle ABC here, and I said the median of triangle ABC, that connected a vertex to a midpoint right here. That was supposed to be an M. There we go. All right, so those two are that was the median of a triangle, and that meant something very, very different. Okay, so a lot of times in math, just in general, we recycle a lot of terms. So we're just going to need the context here. This is the median of a trapezoid, not the median of a triangle. All right, give me one moment here. Special guest, Dr. McCowan.
Hi, guys. You add the top and the bottom, divide by 2, and it gets the middle.
That's true. She
Is
was
that what
math.
we're doing? Is that what
Yep.
we're doing?
Median of
All
trapezoid.
right.
All right. Thank you. All right, so let's see here. If blank, the medium of trapezoid, all right, so if MN, segment MN is our, let's see here. If MN is the median of the trapezoid, then, yeah, they just totally threw me off. All right, what was I saying here? Of the trapezoid. Oh, wait, I know what I'm supposed to say here. How about AB, A, B, C, D. All right. So MN is the median of trapezoid A, B, C, D. Then what can we say? Well, let's just kind of think about a trapezoid. We said the top and the bottom bases are parallel. So what we can say is I can say also MN is parallel to AD. I can also say that MN is parallel to BC. All right. So all three of these guys are parallel. And that's kind of nice to think about. All right. Is there anything else I want to say about this? If Mn is a median of the trapezoid, then I think that pretty much sums it up. All right. So let's move on to an isosceles trapezoid here. All right. So if I think about isosceles, where have we heard that word before? We've had isosceles triangles. All right, what was an isosceles triangle? An isosceles triangle was just a triangle where two sides were the same and we called these base angles, remember? The two base angles were the same. So here's what I'm going to do. I am going to take a line that is parallel to the base. All right, so these two lines are parallel. And if you remember, here's another idea from Unit 5. If we have parallel lines, then these two segments get cut proportionally. Okay, they're not necessarily equal to each other, but the top two are going to be equal and those bottom two are going to be equal. All right, so here's what I can do. I'm going to take this isosceles triangle and I'm just going to chop off the top here. And what do I have? I have an isosceles trapezoid. All right. So the definition of an isosceles trapezoid is, first and foremost, a trapezoid. A trapezoid where I'm going to say the non-parallel sides are congruent. All right, so I'm going to use our congruent symbol here. All right, we call these legs. All right, so the legs. The legs are congruent. So let's see here. Why don't we, I'm going to say AD is congruent to BC. All right, we have that. And then we know that those are parallel from before. All right, AB is parallel to DC, and AD is congruent to BC. And actually, I was getting ahead of myself here, so I can say here the legs. The legs of an isosceles trapezoid are congruent. All right, so I'm just basically rewriting that. Here's a bonus feature. So AC and BD, those are what we call diagonals. All right, so they are connecting the opposite sides. I'm sorry, the opposite angles together. The diagonals of an isosceles trapezoid are congruent. All right. We can actually prove that one pretty easily if we wanted to. I think this is just going to be one of those situations where you're probably going to want to take my word for it. Um, for the sake of time, but I am more than happy to prove this one in class. If you don't believe me, that's fine. All right. What it basically boils down to are, some triangle congruence theorems, and we got some reflexive sides, we have some reflexive angles, all of that good stuff. But yes, those diagonals are going to be congruent. All right. Let's see, what else do I want to say? Each pair of base angles. Each pair of base angles of an isosceles trapezoid are going to be congruent. I think I talked about this in the previous slide when we were first defining or just deriving what an isosceles trapezoid is. All right, so basically those bottom two angles are going to be congruent. So I can say angle D is congruent to angle C. And angle A is congruent to angle B. All right. Now, I guess another property we could say here is keep in mind these are parallel. So what can you say about angle A and angle D? Right? Angle A plus angle D. Well, those are same side interior angles. There's a unit 2 throwback. All right. That is equal to 180 degrees because same side interior angles of parallel lines are supplementary. Similarly, angle B plus angle C equals 180 degrees. All right, and that one's done, right? So that's what an isosceles trapezoid is. That's pretty much everything I want to say about those guys. So the big kind of thing to remember in this section is what a median is. All right, a median, you take the top one and the bottom one, you add them together, divide it by 2, and that's going to be the middle piece. All right, all three of the lines are parallel. Isosceles trapezoid, the two legs are the same, the diagonals are congruent, the base angles are congruent, right? So that pretty much sums up everything we have here. So if we look at this next one here, we are trying to find XY. All right, XY is our median All right, I'm going to call this top one base 1, call this bottom one base 2. We know our median is equal to base 1 plus base 2 divided by 2. Okay, let's plug in what we know, right? We don't know the median, so we're going to leave that as our variable. The median, m in this case, equals, well, AB is 3, CD is 7. We just chop that in half. All right, 3 plus 7 gives us 10. We have to divide it by 2, so we have 5. All right, so our median, in this case, xy, if we wanted to rename it xy, is just equal to 5. All right, so let's look at the next one, slightly different. All right, let's see what we have here. XY is 30, AB is 20, and CD is, well, we don't know what CD is. We got to find it. All right, so once again, the median is equal to base 1 plus base 2 divided by 2. Now, plug in everything we know. If you notice, this time we do know what XY is. I guess if I wanted to, I could change this. I could, if I wanted to be a little bit more strict, I could say XY equals AB plus DC divided by 2. All right, so that's what our formula looks like if I were to plug in all of the segments. In doing so, I get 30. 30 equals, we have, well, we know AB is 20. So we have 20 plus segment DC. Right, and we want to divide this by 2. All right, now, slightly different because we know the median and we are trying to find another base. And the problem with this is we have that divided by 2 going on there. All right, so 20 plus DC, that whole thing is getting divided by 2. So a little bit of algebra. How do we cancel out a divide by 2? Well, think what's the opposite of divide by 2? Right, just multiply by 2. Most important rule of algebra, whatever you do to one side of the equation, do to the other. All right, so what we will end up with here is 60. 60 equals, now we have to be careful on this one. The most common mistake is people are going to want to distribute that 2 up top. Don't do that, right? The whole purpose for multiplying that 2 is so we can cancel it with the 2 in the denominator. All right, so those are gone. So what we're left with on the right side is 20 plus DC. All right, and then just get rid of the 20. All right, subtract it over. We have 40 equals DC. All right, and that one's done. All right, so slightly different. But, if we wanted to confirm it, what is the top plus the bottom? That's going to be 40 plus 20, and then divide that by 2. All right, 60 divided by 2 gives us 30, which is what that median was. All right, last page here. LM is the median of A, B, C, D. Find the values of X, Y, and LM. So the first thing, I'm going to find Y first here because I don't know, it's off to the side. That one stands out. So point L, we know point L is a midpoint because it is a median. Remember, the median is where the two midpoints connect. Right? So that means these two segments are equal. Well, hey, that means this guy down here is a 3, right? So if we add those two together, we know that entire side has a length of 6, right? That side is represented by 6y minus 4. 6y minus 4 equals 6, all right? Add the 4 over, we have 6y, I'm going to go horizontal here, equals 10, all right? Divide away the 6, and we're going to have y equals 10 over 6, all right? And we see that, and we panic, right? Because that's a decimal answer. We don't like decimal answers, right? So all I'm going to do is just reduce the fraction down, and that's just 5/3, all right? Don't call it 1.6, just leave it as a fraction, okay? There's nothing wrong with 5/3 as an answer, but don't you dare call it 1 2/3, all right? Leave it as 5/3, okay? Now, let's figure out the last one here. So here's our median. Here is base 1, and here is base 2. All right, we know the median is equal to the top plus the bottom divided by 2. Let's plug in everything we know. We have, what do we have? We have 3x equals x plus 2 plus 3x plus 4 divided by 2. All right, easy enough. What I would recommend we do first is how about we combine some like terms? All right, so look at the right side. I got a whole bunch of x's on top. I see 4 x's on top, and then plus a 6. All right, we're going to divide that by 2. All right, and here's what I'm going to do. I'm going to write this twice because there are two different ways I want to do this problem. Right? Now, if you kind of think back to the previous page, what we did is we multiplied both sides by a 2 because we tried to cancel out those denominators. All right, so the 2's are gone on the left. How about on the right? The 2 are gone on the right. But if you look at the left, we have 6x. So 6x equals 4x plus 6, subtract away the 4x, and we have 2x equals 6. Therefore, x equals 3. All right, so that one's done. But another way you could have done this one, notice how 4x and 6, all right, those are both even numbers. Even numbers we can divide by 2 pretty easily. All right, so instead of multiplying the 2 over, sometimes you can, if everything is even, all right, we're just going to have 3x equals 2x plus 3. Right? Just divide them both individually, subtract the 2x over, and you have x equals 3. All right, both of those are perfectly fine ways to solve this problem. All right, so x is 3. That was the hard part. Don't forget about the easy stuff. All right, we have LM here. So LM is just 3x. Well, x we said was 3. All right, so that equals 9. All right, LM is equal to 9. And that one's done. All right, I got one more for you. Segment shown below is a median. Here's what I'm going to do. I'm going to do the angles on this top one, and then this is the same picture down here. I'm going to do the side lengths down here. All right, so if we just look at the angles, we are going to have to remember a lot of stuff about parallel lines, right? So this is early days geometry when we kind of first met each other. What did we talk about? We talked a lot about parallel lines. All right, so these lines are parallel. Again, we know they're parallel because it's a median, so we're going to have to use that definition. Well, what do we know about B and 80? Those are same side interior angles, right? What do we know about same side interior angles? They are supplementary. So if I wanted to figure out what angle B is, all right, all I can do is just say B plus 80 equals 180. Okay, that's what your setup looks like. If you're capable of skipping straight to the answer, of just knowing that, oh, they're supplementary, it's got to be 100, that's totally fine. All right, but if you look at 80 and A, what do we call those angles? Those are corresponding angles. What do we know about corresponding angles? Well, corresponding angles of parallel lines, of course, are congruent. All right, so that means angle A is 80 degrees. Right. Similarly, if you look over here, I got a 120-degree angle. If I look at this angle C right here, those are also corresponding. So we have C equals 120, right? So there's some stuff back in Unit 2 that we talked about way back September, October, maybe. Right? It's going to be really useful to remember that kind of stuff. All right. So those are the angles. I think those are the angles. Here, I got some room. Let's find Z. So we know Z is, just that bottom half there. But this point right here, since we do have a median, we have a midpoint. All right, so that means each one of those pieces is 13. All right, so Z, if you want to think about it, you could throw a Z up here as well. And you could say, all right, 2Z equals 26. Divide both sides by a 2, and we have Z is 13. All right. And that one's done. Now let's move on to, I guess, the more difficult part here. Finding that median here. So I got base 1 on top, base 2 on bottom, and of course, the median right in the middle. All right, so oh wait, I forgot it. Y is 11. There you go, spoilers. Y equals 11. Sorry, I forgot that. All right, last one. We know the median is equal to the top plus the bottom divided by 2. All right, so let's just plug in everything we know. I know m is x squared. All right, base 1 is 2x plus 1. Base 2 is 3x plus 2. All right, and we divide all of that by 2, right? We're just chopping it all in half. So first things first on this problem, before we start moving stuff around, it's going to be useful to combine any like terms, condense anything that we have. So I got a 2x and a 3x. That's going to give me 5x's total plus a 3 all over 2. All right, now, if you look at this one, it's kind of like the same situation up here. So we had, some variable equals, we got a fraction on the other side. If you look at this orange one here, we were capable, or I guess we were able to divide both numbers by the 2 because they're even. Right? But if you look at this guy, you got a 5x and a 3. All right, that's not going to get us some nice whole numbers. I don't want to deal with a 2.5 and a 1.5. So instead of dividing those out, let's get rid of them. All right, let's just multiply both sides by a 2. Remember, a fraction is just division, so that 5x plus 3 over 2 is 5x plus 3 divided by 2. All right, these 2's on the right side cancel. We are going to have 2x squared equals 5x plus 3. All right, and now I see an x squared term. I see an x term. I see a number. So this is going to be a factoring problem. So I would recommend keeping the 2x squared term positive. It's not impossible, but whenever you have a negative x squared term, it just makes factoring a little bit more difficult. So keep that 2x squared positive, and what I'm going to do is I'm going to subtract both the 5x and the 3 over to the other side, right? We're just going to set it equal to 0. Now we can factor this guy. So let's see what we get. This all equals 0. So normally, this is a difficult kind of factoring problem because that leading coefficient there is a 2, or it's something other than a 1. So normally we just go x and x and we call it a day, right? But we can't do that because we have a 2x. So I'm going to throw the 2 right here, right? Because if we look at that, these two, when we multiply them, that gives us 2x squared, which is what we wanted, all right? So now, we always multiply to the n terms. All right, so you're multiplying to get 2x, you're going to multiply to get to the 3. But now it does matter where the numbers go here, right? So what I'm going to do is I'm going to put, what am I going to put here? I'm going to put a 3 right here and a 1 right here. And I'm going to do that because let's multiply these. All right, 1 times x, that's just a 1x. 2x times 3, that gives us a 6x. All right, we're trying to build a -5 out of that. So what do we need? We need to have a negative 6x and a positive 1x. All right, so to get the positive 1x, I'm going to put the plus in front there, and then I'm going to put the minus sign on the back end there. But keep in mind, we chose this order because, look at these two now. If I multiply the last terms, positive 1, -3, that gives us our negative 3 there. All right, so everything, it all works out here when we are factoring. So that was the hard part. All right, factoring is always the most difficult part of, these types of problems. So don't skip out on the next part, the easy part. All right, you're going to take each factor and you set them equal to 0. All right, so we got x minus 3 equals 0 and 2x plus 1 equals 0. Now, these are like just two miniature equations. All right, so subtract the 1, divide the 2, you got x is equal to -1/2 and x equals a positive 3. Now, that's two answers. Anytime we have two answers, that's always kind of a red flag here. So let's plug them in. Let's see what happens. I'm going to plug the -1/2 in to this problem. Here, I think I have it down here. So if I plug in x equals -1/2, let's just see what we get. We have 2 times -1/2 plus 1. 2 times -1/2 is -1 plus 1 equals a 0. All right, so what that means is that tells us this side length here is 0. That doesn't make any sense. All right, if that had a side length of 0, then this shape here would be a triangle, all right, which it's very clearly a trapezoid. All right, so this x equals 1/2 is no good. All right? If I were to plug in the 3, all right, 2 times 3 is 6. 6 plus 1 gives us 7. If I plug in a 3 here, 3 squared gives us 9. All right, and the last one, 3 times 3 is 9, plus 2 is 11. So let's look at this. We know 7 plus 11. If we chop that in half, that's going to give us 18 halves, which is equal to 9, which is this term right here. All right, so the x is equals 1/2, -1/2 is no good, but the x equals 3, that's the answer that works. All right, so there we have it. There's a couple of examples. This bottom one here, that's kind of worst case scenario because we had a factor. All right, but that was pretty much everything I wanted to talk about in 8.6. So if you have any questions, ask me next time you see me, but otherwise we are going to end it there, and have a good day.